Good afternoon, welcome. I want you to picture this. You have a brilliant idea. You're excited about it. This idea can potentially change the way your team or entire organization operates. That's going to be your career changer. You're ready to run with it, you've got the momentum, you put the plan together, you've got a list of stakeholders, you call that meeting with your leadership team, you present the idea, the excitement in the room is palpable, you're ready, and then you get the question. Yeah, but how are we going to fund this? We're out of budget this year. Or maybe somebody says, nah, we tried this before, it just doesn't work like this here. Or maybe somebody says, great idea, but, our roadmap is locked for the next 12 months. Does that sound familiar to anyone? Can you raise your hand? Right. If you've been there, you know that real innovation can sometimes feel like a race with obstacles, and the biggest hurdle is actually red tape. Today, we will talk how to set up the foundations for continuous innovation and experimentation in your organization. You will hear directly from Formula One about their innovation journey and latest technological breakthroughs. With that, a phrase I wanted to say for a very long time, lights out, and away we go.
The future is coming fast. F1 drives its data with AWS to generate performance, generate statistical insights, generate excitement, generate a whole new era of fan experience. Now, with generative AI, lights out. Time to accelerate.
I would like to begin with a simple but powerful question. What does it take to make innovation a continuous process instead of a one-off event? When Formula One and AWS first joined forces in 2018, our primary goal was to accelerate F1's transformation into the cloud. We wanted to lay the foundations for the next wave of innovation. Fast forward 2022, we renewed our partnership, and this time with two very bold and aspirational goals. First, we wanted to bring in that new era of innovation and transformation to the entire sport. And second, we wanted to create a blueprint for continuous innovation that other organizations, large or small, can emulate. It's quite aspirational. In the past 24 months, our teams have been fueling F1's high-performance operations and reinventing the way fans engage with the sport. And today, we will share some of the solutions that we have developed together. You can imagine that delivering on such a bold vision requires quite a bit of careful preparation before any work even begins. F1 and AWS aligned on the following core priorities before we started the work. First of all, we wanted to embrace the possibility of failure. We know that failure is going to happen. We will get things wrong. But with every failure, we get a new data point or a new insight that actually takes us closer to the breakthrough. The key here is to ensure that this experimentation and learning cycle is not left to chance. We want to create mechanisms that scale and repeat themselves. Second priority, we wanted to ensure that both of our teams can act decisively and independently. We wanted to unlock their speed and creativity. And last, we wanted to create velocity in experimentation. We wanted fast iterations that give us faster insights that we can feed back into our initiatives and that get us closer to the right solution sooner. So every team, every partnership, every organization need to figure out what's the right balance of the three priorities. So think of this as a recipe, right? So the right mix, a balance of ingredients will depend on your risk appetite, on the size of your team, and the problem that you're trying to solve. However, the speed of experimentation was not our only focus. When we talk about doubling the number of experiments to double our inventiveness, we also think in not just the volume, it's about intent and execution. Some organizations shy away really from this kind of high volume experimentation. And when we talk to business and technology leaders, what are the reasons for that? We usually hear two main reasons. The first reason is that kind of concern around taking the focus away from your core product. And the second concern is actually that the cost of experiments can get out of control. What we have discovered is the following. The cost of experiments is actually usually small. It really gets expensive when these experiments work out, right? And arguably, this is a pretty good problem to have, right? As a business, we want that. So what we want to do with experiments, we want to design them to be fast and actionable, and at the same time, we want to empower that experimenting team to act decisively once they get the insights. Consistent innovation cannot solely rely on extraordinary individuals. We need them, but we also need mechanisms that allow us to scale beyond individual impact. In our collaboration with Formula One, to ensure that all initiatives receive the right amount of attention, we created an innovation framework. This framework allows us to generate and capture ideas, align on priorities, and only push forward with good ideas. What this innovation framework and this mechanism also did for us is actually we created a separate one to discard of bad ideas. Yes, we did have plenty of bad ideas. This is not a common thing to see in organizations. Can you show me your hand if your team or your organization has a good mechanism to prevent bad ideas from developing further? Okay, that's what I expected, thank you. I think it's normal. As individuals, we really tend to kind of be guarded about our ideas. It's hard to admit that our idea is not the best fit, maybe it's not good, or maybe it's not the right time. So having a mechanism to deal with this allows to take that personal element out of the process. At the core of our innovation framework was Amazon's working backwards approach. It is an approach and methodology that we use at Amazon to develop and launch all of our customer-facing initiatives. It's a process of creating a written narrative, a fictional press release, and frequently asked questions. In this press release, we imagine a time in the future, we've launched a product, and from that point to ourselves today, we described how do we announce this launch? What are our customers saying? What's the customer experience? And having this written narrative allows us to gather feedback early on in the process, iterate on initiatives, and get ready to run fast once we are ready. We use exactly the same mechanism to prevent bad ideas from developing further. The next point I want to make that it's not enough to just have great ideas. I doubt there's any representative here who comes from a company where you have no ideas, right? We have plenty of those. But what we also need, we need organizational structure that allows teams to act effectively and efficiently on the ideas. While there is no one-size-fits-all, we, for example, at Amazon use what we call two-pizza team. You might have heard about this. We are organized in small, nimble teams, autonomous decision-making. What it allows us to do is allows us to kind of reduce the time spent on communications between the teams. It frees up the time for teams to think big and innovate. And one important part, it creates more capacity for us to experiment. In our collaboration with Formula One, we organized our efforts around a cross-organizational team of about 8 to 10 people. Every team member of that core team has very well-defined roles, responsibility, and accountability. And more importantly, this core team was empowered to make all daily operational decisions without relying on any external approval. Additionally, Formula One dedicated a small annual budget specifically for that core team to fund prototypes and POCs outside of existing funding cycles. So having these structural choices allowed us to reduce organizational inertia and also reduce delays. I want to bring your attention to this point. We're not trying to eliminate inertia or delays, but we're trying to reduce it to the point where the velocity is right for us. Structural autonomy alone is also not enough. Innovation also requires a disciplined approach to decision-making, right? We rely on single-threaded ownership that ensures that there's always one business leader whose full-time job it is to think about the problem that we're trying to solve. They are in charge of pushing the progress forward, aligning resources, removing obstacles. So this approach allows us to move faster, and it removes these inefficiencies that the shared ownership model can bring. In our partnership with Formula One, we initially started with a steering committee as a governance model, and we very soon realized that this is too slow for the type of daily operational decisions that we need to make, and we shifted towards the single-threaded ownership. As a result, again, even greater speed, fewer dependencies, and the structure that allowed us to move each initiative through the pipeline faster. Same time, not all decisions are made equal. At Amazon, we have a concept of a one-way and a two-way door decision that allows us to balance the speed and the quality of decisions that we make. A one-way door type decision is the one where the consequences are pretty high or costly, depending on the context, and we want to spend more time aligning and debating on that type of decisions. On the other hand, two-way door decisions, a majority of the decisions that we make in our professional life. It's a type of decisions where we can reverse the consequences. Maybe they're not too costly. So we go through the door, we see what's on the other side. If we like it, we continue. If we don't like it, we go back and we choose another door. We also learned to act fast. We have a rule of thumb to proceed when we have 70% of information we wish we had. If we are waiting to get 80% of information or 90% of information, it's nice, but it's too slow. And we know that we can be late and innovative at the same time. With all that said, experimentation cannot be done for the sake of experimentation. We also don't want to move fast, but without the purpose, right? The innovation is not the purpose on its own. The impact of that innovation is what we are after. So with Formula One, every decision, every mechanism, every experiment that we created always served one purpose: delivering impact where it mattered the most. For F1, they had really great clarity where that impact should land. They were going for faster, smarter decisions on the track, and deeper, more meaningful experience for the fans. And it was all about turning that innovation into impact. And that's exactly what we have achieved. I'm now honored to invite David King, Head of Digital Technology at Formula One, on stage to share their innovation journey and recent breakthroughs. Thank you, David.
Thank you, Olga. Because it feels like a bit like being in an F1 paddock with the wheel guns in the corner, so I'm glad you've all got headphones. Before I start to tell you about F1 and some of the innovations we've worked on in the past couple of years with AWS, I want to take a moment to reflect on and pay tribute to Pete Samara. Pete was a loving husband, father, brother, and colleague. He was intrinsic to the relationship that we have with AWS and the way in which we tackle innovation. So Pete, thank you for instilling within F1 that same passion. So what is F1? You've probably heard of it. Some of you have probably watched some of our content. You might even have been to a race. Was anyone in Vegas 2 weeks ago? No? Couldn't do 2 weeks in Vegas? Okay. But how many of you appreciate the challenge that we face? So, F1 is the commercial rights holder of the FIA Formula One World Championship. What that really means is that we as an organization get the opportunity to organize 24 events a season and bring that to the world. Our audience is spread all around the world. Yes, centered quite a lot in Europe, but we have 1.5 billion people in 2024 who will have watched F1. Growing markets in the US, with 1/4 of our races now in the Americas, and 6 million people who will have been to an F1 event this year. So what do we do? What is our mission? We're striving to create a truly global spectacle. And I think this season we've achieved that. When the final checkered flag of this season falls in Abu Dhabi this coming weekend, we'll have completed a record-breaking season of 24 events. 5 continents, 21 countries, 5 double headers, that's a race weekend, 2 in a row, 3 triple headers, 3 race weekends in a row, just like the one we're in at the minute. It's quite draining. A really demanding schedule, but one that our team has stepped up to. We strive to create a positive and inclusive environment, not just within our organization, but within motorsport more generally. So also next weekend, we draw to a conclusion the 2nd season of the F1 Academy series. It looks to develop females and female drivers and personnel within the teams to progress to higher levels of competition. Sustainability is also at the core of what we do. From 2026, the F1 cars on the circuit will use fully sustainable fuel. From an organizational perspective, we leverage sea freight in favor of air freight where we can. If we can't use sea freight, DHL now use sustainable aviation fuel. The other key initiative that we have in terms of sustainability is our remote operations model. And we'll come back to this a couple of times through the presentation because it split our operation in 3. And whilst it had some really positive benefits in terms of sustainability, it presented some real technical challenges. And the last point, being at the cutting edge of technology, we're not a team, but we're a 75-year-old sport. And I think it's reasonable to say we're at the cutting edge. We're doing some really interesting things, from our on-car system, collecting millions of telemetry points during every session, to our remote operations setup, to our augmented reality graphics in production, and to our digital platforms. So what are our business challenges? The top one is quite important for this conversation. We're quite a lean organization. A lot of people will look at F1 as a brand and think thousands and thousands of people. We're about 600 to 700 people spread across everything from legal, commercial, HR, digital, production, rig teams, you name it. We have everyone that we need to put on an event and make it available to the world. Our sport is more data-driven today than it ever has been. We have drivers fighting for every 10th of a second on every lap. And we, as an organization, have to do our bit to push in the same way. We have some very complex data systems and a complex setup in terms of remote operations. But this last point about diverse working environments, we put an event on pretty much every other weekend across a year. Our season's about 11 months. We have some double headers, some triple headers. The teams work incredibly hard. To give you context, it takes about 7 to 10 days to set up for an F1 event at a circuit. To build all the infrastructure, deploy the hardware, connect it back to our base in Biggin Hill. In 2019, we were mid-race weekend in Japan, in Suzuka. A typhoon was inbound, our infrastructure was strapped down, but we didn't feel that was really sufficient. So in the space of 24 hours, our team completely de-rigged our infrastructure, moved it inside the pit building, and reconfigured it so that we could be ready for the race on a Sunday. The race went ahead, we broadcast it around the world. So what are our big bets? Big bets are the goals that Olga touched on. When we think about innovation and we're throwing away bad ideas, ultimately, if an idea isn't driving at one of these three areas, it's either not, might not be a bad idea, but it might not be the right time for that idea. So, high-performing operations. As I said, we move our kit around the world 24 times a season. We moved to this remote operations model where we sent fewer people to the circuit. We deployed less infrastructure at the circuit. We set up a fixed location in the UK, and we have our cloud services. That's a lot of kit, a lot of software deployed in various different places that's got to be monitored, maintained, and constantly evolving. We don't stand still in the sport. In the same way that the teams will come back from a mid-season break with a new aero package, we have to keep stepping up and stepping forward and providing the best experience to our fans. World-class racing. Yes, we're not a team, but we can influence the racing to an extent. 5-10 years ago, we recognized that the racing wasn't necessarily as competitive as it could have been. And we worked with AWS using computational fluid dynamics, high-performance computing, to generate a new concept car, a new set of regulations that would allow for closer racing, more overtaking, and ultimately a more engaging sport. Fan experiences last here, but really it's the thing that encompasses everything. Engaging content, engaging racing. We have a saying internally that it's all about the fans. Without the fans, the sport ceases to exist. But it's quite a complex sport. I was talking to Olga earlier today and talking about the barrier to entry can appear to be quite high. You know, we've got a lot of new fans who've come on board with Drive to Survive, more races in their countries, and actually we need to appeal to them. We need to make available to them the sport, introduce them to what DRS is, what is an undercut threat. So we've worked with AWS to use the huge volume of data that we've got to produce F1 insights. If you watch one of our broadcasts, you'll see the graphics appear on the screen that's saying that if Max pits now, there's an undercut threat for Lando, that he's going to come out ahead of him when he eventually pits. None of the initiatives that I've talked about in those three areas exist as off-the-shelf products. And this works really well and complements AWS, and actually not a note I made, but a good reference. AWS is a toolbox. It's not a product. But what we've done is work with AWS to create those products for our purposes. And I think you're all doing the same with AWS. But all of these things require vision, experimentation, iteration, and actually knowing when to stop, when enough is enough, and parking something. So I'm going to talk to you a little bit about something we've called Track Pulse. And we're actually really fortunate. We've got one of the guys from AWS ProServe who was involved in this project sitting outside the area. Just to be clear. What is Track Pulse? Well, F1 is a really complex sport, as I said. It's also a sport that's got 20 drivers and cars spread around a 7-kilometer circuit in the middle of the Austrian hills. It's not a stadium sport. It doesn't have a single ball. It can be quite difficult to follow. Now, our production teams work really hard to tell the story of every track session, be it a practice session, a qualifying session, or a race. But they don't get everything. They only have so many eyes. They can only look at so many screens and so many data points. So Track Pulse leverages all of the telemetry and positioning data that we have. We ingest it into the system and normalize it in an ECS cluster. We combine that with all of our historical data, and we feed it into our story machine. Our story machine is trying to generate all the stories that are available, whether they're at the front of the order, midfield battles, Ferrari and McLaren fighting for the championship in terms of constructors, but they're further down the order, and trying to bring those to life, highlighting those stories to our production team. So we use SQS and we use DynamoDB to store those stories and make them available to our production team, to our broadcast partners, to our commentators, so that they can know that it's been 12 years since we had a safety car in Singapore, adding interest and really bringing the production to life. So, probably enough of me talking. I'm going to show you a quick video of Track Pulse. 2 clicks.
24 circuits across 21 countries. 20 drivers all out on track, chasing one dream. Formula One brings the action to millions of passionate fans, telling authentic and engaging stories that unfold on the circuit through global production. AWS partners with Formula One to drive technical innovations all the way from pre-season testing to the final race in Abu Dhabi. Just like drivers and their teams, the F1 production broadcast team makes split-second decisions across various data sources to ensure fans around the world don't miss a moment of the action. Real-time access to data is everything. With up to 300 sensors on every car, over 1.1 million telemetry data points are generated every second. Together, AWS and F1 have developed Track Pulse, a single view making it easy for the live production team to identify every story as it unfolds. Track Pulse combines real-time action with historical data to deliver engaging insights to the fans at race pace. Track Pulse, powered by AWS.
Oh, thank you. I can't take credit for the video. We have a great content production team. I'm going to bring Gaurav on stage, who's going to talk to us about the culture of experimentation.
Thanks, David.
I'll give you the clicker.
Thank you. Folks, I know I'm standing between you and beer, so bear with me. Another 20 more minutes and then you're going to have your beer. My name is Gaurav Kaila, and my team and I help customers like Formula One innovate on AWS and build solutions like Track Pulse. You've heard Olga speak about some of the mechanisms to deploy innovation within your own organization, and I'll build on another mechanism called culture of experimentation. We'll hear from David on how Formula One has nurtured this culture within their own organization and built solutions like Track Pulse. We'll talk about a real-world business use case, another use case like Track Pulse, where we have used this culture to produce a solution that provides a real business impact. And finally, the best part, you're going to learn some mechanisms to do the same thing within your own organization as well. But before we talk about culture of experimentation, let's understand what experimentation means, what an experiment means, and why I believe it's critical to nurture this in every organization. Innovation has and will continue to be the center stone to transform industries. And for me, innovation is like an onion with multiple layers dealing with what it truly means. Behind innovation is technology, which is powering some of the biggest breakthroughs. Behind technology is an often overlooked practice of experimentation, a practice of taking small steps, doing your hypothesis testing, doing your trial and error. But you might ask, Gaurav, what does an experiment mean? Given everybody's talking about generative AI, we're going to talk about the same. I posed this question of what is an experiment to 3 commonly used large language models. And if you read the definition produced by each of them, you start to understand what an experiment truly means. It is an exercise, a process that is conducted to prove a fact, to give some evidence. There's one attribute that all of these definitions miss out on, a very critical attribute as we talk about experimentation in an industrial setting, and that's time frame. While you might have 5 years or more to prove out a hypothesis in your PhD in an academic setting, unlikely you'll have the same time to prove out a hypothesis in an industrial setting. Let's deep dive into why time frame and how time frame features when you're talking about experiment-driven innovation. Most companies approach innovation linearly. They start with an objective, set a goal, and march towards it. Now, clearly there's some issues with it, right? First, if the goal is too large, too complex, over time enthusiasm wanes and the exercise fails. Or, which is a bigger problem, over time new stakeholders join the project, priorities change, and exercise goes to fail again. Most innovations are not as straightforward, right? And they take time to understand, first by understanding what is the baseline. What is the current state of what you're trying to do? Taking small steps to get towards that. And from there, taking small steps to get towards your goal. I'll refer back to what Olga mentioned. Experiments fail, and that's absolutely fine. What's more critical is to understand why something fails, putting that failure lessons into your next experiment and moving from there. And you'll notice my experiment actually doesn't meet the goal. And it's absolutely fine as well. It's important to understand and pivot as we're moving along to understand what is good for us. Now, this is not just us saying as AWS or Formula One, but this is backed by data as well. McKinsey estimates that 70% of companies do not have or fail to transform due to lack of innovation or frameworks to implement innovations. And this is where culture of experimentation or the innovation mechanisms that Olga spoke about becomes really critical to have that innovations in place. Now, I'm going to stop talking because you're here to listen to F1. So I'm going to bring David back into the conversation. And David, tell us, what does experimentation look like within Formula One?
Well, Gaurav, I think this quote, if everyone's had a chance to read it, is pretty apt. In 2025, F1 will celebrate its 75th anniversary. And without experimentation and innovation through that time, we just wouldn't be here. We'd cease to exist. Many of you will have used innovations that came from Formula One, perhaps without realizing it. So F1 as a sport. Disc brakes, hybrid engines, sustainable fuels, active suspension, regenerative braking, all Formula One generated innovations that now exist in the real world and have added value. One of our more notable innovations and came through experimentation was the introduction of the onboard camera. It now seems like quite a normal thing. If you watch F1, you get to sit on the car and watch what's happening. But back in 1985 was actually when we first live streamed a video from a car going around a circuit. It's quite difficult to get moving pictures of a car traveling at 230 miles an hour down the strip. But we do it, and we do it every week. We evolved in the couple of decades that followed, and we looked at different camera positions, rear facing, facing the driver, nice low shot for those banked corners. But it wasn't until about 2021 when we took the next real step in the onboard camera system, and that was involving a helmet, and it was the helmet cam. Now, some people might have shied away from interfering with what is essentially a safety device, and quite an important one, really, in racing cars. But we didn't shy away from the challenge because we knew the perspective that it could bring to the viewer and bring them into the cockpit, not just on the car, but actually giving them a driver's eye view of what's happening. But we don't always get it right like that, and Olga touched on this when she mentioned about steerco and single-threaded leaders. We didn't get innovation right this time around first time. We had to make that active decision to move away from that steerco model because it was prohibitive and we weren't innovating fast enough. So the single-threaded model, working with PRFAQs, and working backwards, which was relatively new to me, but not to Amazonians, apparently, and being ruthless about what's good and what's not, and what's relevant for your business goals.
Thanks, David. Now, hopefully that makes it a bit more real how this culture of experimentation and innovation is deployed in an organization like Formula One and how it drives real business value. But let's make it a bit more real. Let's talk about a real-life use case that we all collaborated upon to build for Formula One. This is a problem that impacts F1 engineers on a regular day basis, especially on race days, days which time is very critical. Through this example, we'll reflect back on some of the mechanisms, working backwards, experimentation, and scaling experimentation. I'm going to bring David back into the conversation again, but because before we deep dive into the use case itself, it's important to understand the large and complex IT infrastructure for Formula One.
Well, this picture looked quite different a few years ago. It got a little more complicated around COVID. As Olga said at the start of our transformation journey with AWS was moving some of our applications to the cloud. So we've got about 180 custom developed applications. I'm not talking Microsoft Word and PowerPoint. I'm talking things that have been written and developed over 2 decades to support racing, capture data, acquire feeds, and generate graphics and insights into the sport. But we then threw into the mix the fact that we're now spread over 3 locations. So at the circuit, we have all of our infrastructure deployed around the circuit that captures video feeds, that captures the million telemetry data points that are generated every second. We feed that all back to something we call our event technical center. It's a large structure. I can't call it a tent. I'll get told off. But a structure that sits at the circuit with physical infrastructure that is there because that's where we acquire the data. It needs to be low latency. There are things that just need to happen at the circuit, but we've really reduced the footprint. We built our own custom MTC, so Media and Technology Center, where we host live production, more data processing, graphics production, content creation, the whole lot. And then the third being AWS. So in the cloud, where we're running more of our applications that are less latency dependent. But this introduces a kind of technical challenge. We're now running applications and services in 3 different places, with the people supporting them and using them in at least 3 different places. Some could be at home, some will be at the circuit, some will be at MNTC, and we have to support that. We also have operators who are timekeepers, graphics producers, IT engineers. So we've got a real range of people who engage with these systems. So we're struggling to manage those systems across those 3 sites, given that this whole thing only exists end-to-end for about 5 days for every race. Because as soon as the checkered flag falls, and we do the podium celebrations, we start to take all that infrastructure apart. So triaging and resolving issues is in a really short window. We needed to reduce our resolution time so that we didn't turn up at the next event and start investigating the problem that occurred at the last event, knowing that if we didn't fix it in the 2 days before practice 1, we probably weren't going to fix it that weekend.
Thanks, David. For a Formula One fan like me, these are issues that you don't tend to realize, right? You see the flashy part of Formula One, but these are the real issues that F1 is dealing in the background to ensure fan experience is good for you guys. Now, with this global reach that Formula One has, there's of course complexities that David spoke about, right? And I'm going to give you some numbers. F1 hosts about 18 petabytes of data on S3. It has about 375 EC2 instances, 180 RDS instances across 100 plus AWS environments. It hosts 180 applications on cloud and on premises, managed by different teams and different systems, which makes dependencies between different systems a lot more complex. So during race day, if an F1 engineer needs to figure out why can't they access real-time data through a database, it's hard. They have to go through multiple systems and multiple teams to figure out what's going on. F1 estimates it takes them about 15 to 30 minutes to check whether the database driver is supported, and takes about 2 hours to query the relevant logs. This is critical time being lost when the race itself is about an hour and a half to 2 hours long. So you can start to imagine an engineer is focusing 2 hours to query the relevant logs, and by that time, the race is finished. For critical issues, where F1 estimates it happens once per race day, it takes them 3 weeks of engineering effort to figure out what happened and then resolve that issue, because they're going through multiple teams, including development, operations, infrastructure, and networking. Recognizing this challenge as an innovation opportunity for Formula One, AWS and Formula One collaborated together across multiple teams to come up with a solution. What we built, and we're going to go through a demo of that solution in the next slide, is a root cause analysis chatbot that augments an F1 engineer's work as they debug these issues. But for us, it was first important to realize, what are we building? So deploying the mechanisms that Olga referred to, such as working backwards in PRFAQ, we want to figure out what is the problem that we are solving for F1 and with F1. And what we narrowed down was to build a chatbot that mimics what an F1 engineer would do if an issue happens, just to recreate what F1 engineer would do if an issue like this occurs. For that, we need to understand what they do. So we sat down with F1 engineers, figured out what their working logs was, put it down on a sheet, and that became our baseline. So if you reflect back on the time frame diagram, there was a baseline, that became our baseline. And now from there, we have to continue building on top through small experiments. We ran through a 5-week experimentation exercise. Again, time frame is important. 5-week experimentation exercise to build out the solution. There were a lot of failures, more failures than we expected, but that's absolutely fine. Each failure helped us understand what we're trying to do and get us to the final goal. Let's look at the solution in action. I'm going to play the video. It's fairly self-explanatory, but I'm going to still walk through it when the video ends.
One we're going to do is a database troubleshooting one, and this is sort of based off of an example that Martina's highlighted that happened during a race weekend. So the first question I'm going to ask is, copy and paste. So I can't connect to a SQL database. I think it's my driver that's the issue. Can you tell me if this particular driver is supported to the chatbot up here? So it's come back and told me that yes, actually that this driver is supported according to the information that it has. So the next question will be, can you check the networking? I'm connecting, I might not know what IP address, but I know I'm coming from an IP in this range. I'm connecting to the US West 2 AWS region, and I'm connecting to an EC2 instance with this ID, and I'm trying to connect to port 1433. The chatbot's able to then go and query and see if I would have access. So it's come back and said, based on the network access check it's done, I should have connectivity within that range, and the instance is running and accessible from my network. It's the chatbot app. Can you tell me the health status of the database instance, please? So it's come back and said that the CPU usage is low, it has free memory available, there's no database locks, and there are no heavy or top SQL consumers being reported. And so combining all of those metrics, it's then determined that actually the database does appear to be in a healthy state. And finally, say I've run through all those steps and all of that's okay and I'm still lost, I might now want to escalate this to someone else, and I might want to raise a JIRA ticket to achieve that. Based on our conversation so far, please rate a JIRA ticket about this issue containing a summary of checks we have done. See there it's come back that the JIRA ticket has been raised successfully, it's provided the summary, and the ticket's been logged for further investigation. So if I go over to our JIRA board, this is just like a sample JIRA board for now, but we can see that a new one's been raised and able to connect to a SQL Server database. It's provided a summary and some of the steps that we've tried, and some information for this to then be escalated further.
This is a real issue that happened on a race day. The F1 engineer first wants to figure out why is a database, they can't access the database. What they do is to check if the database driver is supported, ask that question to the agent. Agent goes out, checks the required systems, comes back that the database driver is indeed supported. The next step that F1 engineer takes is to figure out if the networking is working correctly. Again, types that question, agent goes out, checks the required systems, comes back, the networking appears to be correctly. Next, the engineer checks the health status of the database. That works to be fine as well. These are steps an F1 engineer would typically take, but it will take them a long time, up to 2 hours to figure out what is going on. But an agent does it in a few seconds. There's no issue, there's no resolve of the issue. So what does the agent do is create a JIRA ticket with all the steps they've taken. That then is then provided to an escalation team That saves the time for the escalation team because they've already gone through multiple steps and serves as their baseline to help them resolve the issue. So you start to figure out how this reduces time to resolution for not only the F1 engineer but also the escalation teams. A point to note here is these are questions that you don't need to be experienced with asking the system. You could be a junior F1 engineer, ask the same questions, and it'll come up with a response that is required for you. I'm not going to take the thunder away from David to talk about the business impact because that is where we're trying to get to. How does this technical solution help provide results Formula One is looking for?
So it's nicely summarized on the slide. I would let you read it, but I'll expand on it. So the resolution time, obviously something we captured as part of the PRFAQ, was we had a target. I can't promise you that this is the number that we set in PRFAQ, but it's an impressive reduction in resolution time of recurring and kind of issues that our team deal with day in, day out. Whilst in the demo we saw someone more technical engaging with the chatbot, we've successfully democratized the issue resolution because actually that could have been one of our timekeepers who's trying to generate a classification at the end of a race and having a problem, and they can ask in a less technical way, can you help me fix this problem? A byproduct of following this process is taking all of the data from those applications and putting it in one place. So at the very least, if the RCA can't fix the problem there and then or tell us what the problem is, it's nicely packaged up into a Jira ticket to say, here's everything I've done so far, and by the way, here's access to all the relevant log files for that time window where you can go and find out more. It also then helps, obviously, to escalate to the right team because it can get context. It can say, well, actually, this feels more like a networking issue, and it can go straight to the network team without trying to go, well, who should I assign it to? Is that person awake because they're flying back from a race or whatever it might be? So it's given us enough confidence to scale the solution. These are experiments. This is a small step. We've taken a few small steps to get to this point that you see in the demo. But it's given us enough confidence to roll this out further across our estate, bring in different technologies and different layers. The network team are particularly keen to get all of their data pulled into this as well. So we also still need from this, or we still see the need for human in the loop. And I actually saw it in one of the earlier presentations talking about, yes, AI is helping us, but actually what we don't want to do, given the mission critical nature of so many of the systems that we're dealing with, is to let an uneducated user walk through our steps and then be allowed to do something that actually could have a fairly catastrophic impact. So I think it's been really positive, and we've enjoyed going through the process and looking forward to rolling out chatbot to more apps.
Thanks, David. And I absolutely love that, right? We don't build technology solutions for the sake of building technology solutions. We build it because it provides that business impact, the 86% reduction of the resolution time, scaling that culture across the organization. That's the real benefit of why we build technology solutions. Now, I promised that I'm going to have a slide that encompasses how you can get started with the same journey in your own organization as well, big or small. So here it is. And I've nicely summarized this into one slide. Starting backwards, working backwards, that's critical. Working backwards from the business problem, never the technology problem. For F1, that was to understand how can we quickly resolve issues to save F1 engineers critical time during race days. That is the problem we're trying to solve. Working backwards from that, figuring out what experiments we need to conduct to build that technology solution. Next is experimentation. Once we've figured out what we're trying to solve, break it down into small steps. Break it down into time frames you can execute those small steps and execute them. Again, failure is absolutely fine. You should embrace failure, learn from it, and ensure that is inculcated into your next step. And finally, when experiments work, celebrate, scale, deploy those experiments to multiple users, multiple stakeholders, take their feedback, iterate again. And if it's working for you, inculcate that culture across other teams as well. So other teams are doing the same because you're not only working within your own team, but you're working across teams when you're trying to build these solutions. This is just the start of your experimentation and innovation journey, right? We cannot encompass everything in a 60-minute session, but there are other resources out there as well, right? I've highlighted 2 of them here, and I'll keep the slide on for a couple of seconds so you can take a photograph of it. The first is talking about some of the innovation mechanisms already mentioned about, but going a bit more detail. Also talking about other examples of other customers incorporating similar mechanisms in their own organizations. The next deep dives into more innovations that AWS and F1 are doing together. So we spoke about track pulse, we spoke about RCA, but there are other innovations that we're doing with Formula 1 as well. So it gives you a better idea on what we're doing together. If you're interested in what you heard today and like to know more, there are other sessions that are on tomorrow and day after tomorrow. My personal favorite is the Duolingo one, which talks about their culture of experimentation and how they're driving innovation within their own organization. This brings us to the end of our presentation. I sincerely hope you've learned something today. It's a learning conference, so sincerely hope you learned some practices that you can incorporate in your own organization. I know there are other sessions going on in parallel as well, so we sincerely thank you for giving us the last 60 minutes of your time. As I said, I'm standing between you and Beer, so I see Beer already up there. But before you guys go, there's one last request I'd like to make. We obviously give these presentations a lot and like to improve, similar to experiments. So if you can go into your reInvent app, and there should be a feedback mechanism there. If you can provide us some good feedback or bad feedback or constructive feedback, it really helps us improve as we give these presentations more and more. Again, thank you. We'll be in the room for another 15-20 minutes. Come, talk to us, ask us any questions you have. Thank you so much.